Let's talk about the conjugate trick for infinity minus infinity limits. You can see on the page here, my first example. As x approaches infinity, this square root function will get bigger and bigger. Same thing with this square root function. So this is like of the form infinity minus infinity. And this is one of our indeterminate limit forms, meaning like this amount of information isn't enough for us to figure out what the answer is. It kind of could come out a bunch of ways depending on the details. So we have to do some computation to figure it out. All right, and we know from previous limit strategies that one trick in our bag of tricks, I guess, when there's subtraction with a square root that we want to like do something with, we know that the conjugate trick is something that might help. That's what we're going to do here. We want to multiply this expression by its conjugate, and then to keep things balanced, we'll also divide by it. So I want the exact same expression, but with a plus sign between the terms. So exactly the same roots, just with this switch to a plus. And then if I want to multiply that in, I have to also divide by it so that I have a zero net change. So the denominator just stays like this. I've kind of created this denominator, but the magic is that in the numerator, I have the a minus b, a plus b situation. So it comes out a squared minus b squared. My denominator just is what I've made it. And on top, I have the square root of x plus 9 squared, that's x plus 9, minus the square root of x minus 1 squared, so that's x minus 1. Don't forget those parentheses, right? When they're in the root and then squared out, they stay kind of grouped like that. So in this numerator, I really have x plus 9 minus x plus 1, right? That's just from distributing this subtraction. So the x's cancel, x minus x, and then plus 9 plus 1 gives me a 10 in the top. All right, so this expression is equivalent to what we started with. And even though it looks like it might actually be more complicated, the way that it's been rearranged is helpful to us here. Because now we have a constant in the numerator, just a fixed 10. And in the denominator, we have something getting really, really big, plus something also getting really big. So this is like of the form 10 over infinity. And we know that anytime you have a fixed number over something getting infinitely large, that limit is 0. All right, so this is one of the nicer cases of how this comes out, where you multiply and divide by its conjugate, the numerator cancels in a really convenient way, and you can just kind of figure out your limit from there. My next example is kind of a representative of a different type of problem where we still have infinity minus infinity, right? Getting big minus getting big. We're going to do our conjugate trick, and then it's going to take a little bit more effort in this step to actually figure out what the limit is. So let's see what happens here. So we recognize the infinity minus infinity, so we want to multiply by its conjugate. This one, only one of the terms is a square root, but that's okay. So we'll just take this term plus this term. Still my conjugate. And again, I can't just multiply it in, I have to also divide by it to keep things balanced. And I'll use my a squared minus b squared trick on the top. So in the denominator, it's just the denominator I've now created. And on the top, I have x squared squared minus root 2x to the 4th minus x squared. And this one, I'm taking an extra step here just because one of them was a square root and one of them wasn't. I don't want to rush it and accidentally have something off. So in my next step, this square and square root will cancel each other, but I'll still have that grouping set of parentheses that I was careful about up here. All right, so x squared squared is x to the 4th. We're multiplying the 2 times 2 to get the 4. And then we have minus 2x to the 4th minus x, still in the parentheses, like we said. And then the denominator just kind of is along for the ride here. I'll take a step and distribute this minus sign into the parentheses. And I do get a little bit of simplification that I can do. We can combine the x to the fourth terms up here. So I have one of them minus two of them. That should be minus one of them. And I guess I have the space, so I'll make a new step. So that's negative x to the fourth plus x, same denominator that we've had. And so when we got to this step in the previous example, we were able to just figure out, oh, it's a constant over something getting bigger, so it's zero and it's done. But when we do all the work here, we finally get to the simplified version of what we started with. We still have infinity over infinity. So it's not the same indeterminate limit form that we started with. It's just another indeterminate limit form. Right, this gets bigger and bigger. Technically, this, I guess, would be negative infinity, and then here we have infinity. So we have just a different problem to deal with. So we switch gears and kind of think, well, if this started as its own problem and I see the infinity over infinity situation, I know that there's like one major strategy that we use for that, which is divide the top and bottom by the highest power of x you see in the bottom. So that's what I'm going to do. And it really will get us to an answer. It's not going to lead us in circles. All right, so the highest power of x in the bottom is x squared. And I'm going to distribute the 1 over x squared into everything. Negative x to the fourth over x squared gives me negative x squared. X over x squared simplifies to 1 over x. In the denominator, I have x squared over x squared is 1. And I'm going to take this in two separate steps. X is approaching positive infinity. So this 1 over x squared is going to come inside the root as 1 over x to the fourth. Right, because then if we simplified this, we would come back to 1 over x squared. And then separately in my next step, I'm going to distribute that 1 over x to the fourth inside here and simplify my terms. So I have 2x to the fourth over x to the fourth. And then minus x over x to the fourth gives me 1 over x to the third. So we do have a lot of pieces of this expression now that go to 0, the way that this strategy usually ends with, right? So we know that this part goes to 0, and so does this one. And then we have the 1 and the 2 and the root 2 in the denominator that just stay that way. But in a fairly unusual situation, we have this negative x squared term here. So if this shrinks to 0 and this shrinks to 0, that means that your denominator is getting very, very close to just 1 plus root 2 in the end. So just really close to whatever that specific number is. But the numerator is just getting bigger and bigger and bigger in magnitude. And then we're dividing it by this fixed number almost. So this doesn't settle into any one particular number. It just gets bigger and bigger and bigger in magnitude. So I would say this limit doesn't exist. And if I'm going to be really specific about it, because of that minus sign right there, I'm going to say this limit equals negative infinity.